Thanks for tuning in today. I'm John Holmes, owner of Holmes Hobbies, and today we're going to go over upgrading the TRX-4 with a brushless motor and ESC system. Today we're going to go through the installation and selection of a brushless motor system that you would put in your TRX-4 for upgrade purposes. And we're going to go ahead and remove the electronics. I've already done most of the changes that we would need to do to get the stock components out. Already taken the motor out, and I've replaced it with a Revolver motor. This is actually a sensorless motor. And so what we got to do next is essentially yank this out with a little help from our side cutters here and solder up the new system, then do the installation and do some testing. So we're going to go over to the shop, do some installation of the bullet connectors, or the battery connectors onto the ESCs, and go from there. So next up in our process, we're going to be adding a battery plug and also the JST plug to our ESC so that we can power our servo with this, and of course plug in our battery to the plug. Now, I have switched over to using the XT60s. I've been using Deans for, wow, a couple of decades now, I guess. And the XT60s, they spark less. They seem to have a more secure connection. They're easier to push together though, and they're also easier to get apart once you get your hands on them. Just a little bit more grip for the fingers. So I've really been digging these XT60s, and as I do new electronics on every rig, as I get new batteries, as my old ones wear out, we're just switching them over one at a time, and over the next few years, hopefully my 30 some odd rigs will all be XT60s, and I won't have to continuously carry all of my Deans adapters to XT60 adapters in my pockets. But at any rate, we're going to get going here. I am using the Zytronic or XY-tronic LF3500 soldering station. It's a pretty high wattage station, and it's got a huge tip on it. We have to use this for a lot of the soldering work that we do here, just because of the thermal mass of some of our motors. Getting the leads on and off those motors can be extremely difficult without that large thermal mass and without the large power that solder station has. It just helps with the recovery time. It bounces back quicker. All right, so we got our insulation on the leads here ready to go. Want to make sure that we have positive and minus proper, and then we just add a little solder and off to the races. So first we pre-tin our connector. Get a little solder in there. You always want to apply the solder to the item that you're soldering, and not to your soldering iron itself. This is a little battery soldering jig that I got from probably Hobby King. I've made a few over the years, but this one was inexpensive and already made. Add a little heat to the joint, a little solder in between. Get that solder flowing. And same for the next side. We're going to pre-tin this joint. What we want to do is heat up the plug and then add in solder to the plug itself. We're not adding solder to the tip of the iron, but to the object that we're soldering itself. Put our thin wire in first. Just give her a little tack to make it hold. And then put our power wire on top of that. And sometimes we need to add more solder on top of all this so it kind of forms together. Sometimes we don't. I'm going to add a little bit more solder. Adding a little bit of solder also helps the heat flow. There we are. Ooh, a little hot. All right. So if we get a close up on this, we can see that there's no gaps. And there's solder all the way in between everything, and it's not a cold solder joint. So if we go to move it and try to bend it, it doesn't just break right off. So soldering is a kind of a long-term skill. It takes more practice than anything else. It's not really a difficult task, but it takes a little bit of fine motor coordination and just really kind of figuring out how your solder works. We use a lead-free solder, and it's extremely difficult to work if you're not quick about things. It just kind of hazes up. It doesn't like being worked over and over and over again. Figured I'd go ahead and just solder up 2 ESCs here. That way we can do some testing. Add our small wire in first, just kind of tack it into place. Power wire in on top. And I can tell we're going to need a little bit more solder, just kind of make everything meld together, get the heat transfer. The solder that Castle Creations uses on their speed controllers does not seem to contain silver, and so it's got a really high melt point, and it just takes a lot of work to get it going at first. All right, that's decent. And on to the next. Again, we want to pre-tin this connector. So we got to get heat enough on the connector itself to transfer heat. And then, yeah, I see it wet right in. Sploosh. And I'm going to pre-tin this connector just a little bit. And this is generally what we would do, is add a little bit extra to the tip of these wires. And these are already pre-tin wires, but like I stated, the solder that Castle Creations used does not seem to have any silver added, and so it's got a really high melt point, and it just doesn't like to mix in with any other solder unless it gets really hot. So adding a little bit of silver bearing solder helps. There we go. Wait for it to burn my hand. That's what we're waiting for. There we go. And done. And we'll use a heat gun or whatever and shrink that down. We're back here over at the hobby house, and we're gonna take apart this XL5 stock ESC. Pretty good ESC, honestly, for stock. It's got this little JST plug on there that lets you power a winch or power lights or whatever you need, or in our case I've got a SHV 500 servo on there, which uses a direct 3S LiPo input from this lead, and then it also has another lead that goes to our radio for controlling the actual servo, which makes it kind of neat. You don't need to have a BEC or anything like that to power your servo well. So we're just gonna cut the leads on this XL5 because I don't really need it, and if I'm going to install it somewhere else, I can always resolder these in. So, got the lead cut. Just need to pull that through. Underneath the battery tray, which you can see I've pulled up, there's this zip tie here that keeps it from getting pinched when they install. And I'd like to keep the shift servo there intact and not have to do another lead. So, just a little bit of that, a little bit of this, bam, lead is out. Now, I'm actually going to install 2 ESCs into our rig. I've got the Mamba X, and then I've also got our Trailmaster BLE Pro ESC. I have the BLE Pro set to dithered mode, which is a higher frequency when it's running, but a lower frequency during startup, which gives us a lot smoother startup. Now the Mamba X has a pretty smooth startup as stock, being a much newer controller, much newer hardware on there. It gives you a little bit more flexibility, I think, when you're designing parts. When you get that newer hardware, you can do things like smoother startup, so that's what Castle did. So we're going to be able to test which one actually works better sensorless. So we just need to find places for these components where they fit. And what I'm thinking is we'll just put the BLE up here, about like so. We're going to zip tie that guy in. Then the Mamba X can go to the side where the stock ESC would sit. So I'm actually going to install the X first so that we can route this underneath the battery tray. I'm not really fond of this battery, the wire routing underneath the battery tray, because every time I change electronics, you know what, I'm not going to route it under there because I like to change electronics a whole lot. So I'm just going to bolt this tray back down. And I've got these VP drivers, Allen drivers, really good quality. I'm pleased with these. The tips of them are machined in Taiwan in a gear cutting factory, and then they make the handles in the US Vanquish factory. And the reason why they're doing this is more than likely because once you get a factory going for whatever you're good at, it's kind of hard to switch gears and do something different. So VP is really good at machining aluminums. They're really good at, you know, press fit bearings, structural parts, but they're really not set up for machining tool seals, gears, stuff like that. They don't have, you know, a hardening facility there. They don't have a tempering facility there. And so partnering with another factory to make these hex drivers really just makes sense for a company like that, because at some point you run into an issue where, you know, having more employees or buying more machines just really isn't the best idea for a company. So they're doing the best of both worlds by mixing their production with sources of you know, outsourcing some of their work, which is working out for them. All right, so I think the Mamba X can go about right there, and then we will go ahead and zip tie the BLE into there. And you would think, since I do electronics for a living, that I would be pretty good at wiring stuff in cleanly, but I end up switching electronics out so frequently that I don't always finish them up cleanly. That's probably my downfall. All right. I guess I may have wanted to wait to put this battery tray back down, huh? It's a little hard to fish that through. Yeah, we'll figure it out. No big deal. Just fish it through the other way. Nope. You know what? This is what putting rigs together is a lot of. Putting them together, taking them back apart, putting them together, taking them back apart. But that's how you learn. There we are. And this is a 2mm driver for reference to take this battery tray out. And to do this sort of work, you really only need to take the front 2 screws out, and then you can lift the tray up like so. And there we go. Nice and easy now. Plenty of room to work. Just going to fish that through there. Now, if we were using a full-size battery pack, like a 5,000 milliamp hour pack, there wouldn't be enough room to install like this. But since we're using a small 1400 or 2200 milliamp hour pack, plenty of room to do this. Not a big deal. There we are. Cool. So make sure this goes down. Bam. One ESC installed. Go ahead and trim this, being careful not to cut any of our power or phase wires. And now Mamba X. And I think I'm going to put this Mamba X either this way. Let's see how it fits. Doesn't quite fit there. I'll put her in sideways like this. Now, one thing that I would mention, the Mamba X has an on-off switch, and it is you know, somewhat waterproof. Has a little silicone sort of covering over the switch body, but on-off switches fail in crawlers very often. It's probably the most common failure that I have seen in my lifetime. None of the controllers that we have at HolmesHobbies have power switches because of this failure problem. And usually what I'll do is just hack these leads off, twist them together, solder them, and so the ESC is always on. In this case, I forgot to do that when I was soldering on the battery plug, so we'll just deal with it. And it'll probably fail. But when it does, we'll know. We'll know that that's what happened. All right, go through here. And again, kind of a little, you know, haphazard installation here, but I'm probably not going to be keeping these ESCs in for very long. It'll do for now. Good for testing. right, just need to make sure we have enough room for all of our wires. Make sure that this reaches all the way over to our radio. This will reach there. This plug reaches over here. Good to go. All right, so that's the installation of our electronics for the most part. Now, when you're going to select a brushless system for any rig, you have a couple of things to consider. And the main one is that you get the right speed of your motor. And of course, running the right voltage to get the speed out of the system that you want. The stock motor, let's see if I have one around here still. No, I don't. The stock motor is a 21-turn Traxxas 550 motor. And that is about equivalent to about 2,000 kV motor. And so if you get a motor that's anywhere from like 1,800 to 2,200 kV, you have a pretty close to stock speed. And what I've selected is the 1,800 kV Revolver 540. And the reason why I selected this is, number one, it's sensorless. I wanted to try something that is, just rock solid all the time, doesn't have very many things to go wrong with it. One thing that we do want to watch out for on an outrunner, this is an outrunner, so the outside of the case spins, is that we want to install it with nothing rubbing on the can. And so, say this wire that goes to the servo, if we just loop it through the normal, routing here, it's gonna be kind of floppy and it's gonna want to ride on this can possibly if we hit some bumps or anything, or if we don't pull it tight enough. And so what I'm gonna end up doing is zip tying this down to make sure that it does not touch the can. Another thing to look out for is the shift wire for your front differential lock. And that has the potential to come over and touch. Right now it looks like it's good, but I'm gonna have to keep an eye on that, because if we wear through that plastic sheath, then the shifting is gonna be off and it won't work as well as it should anymore. Right, so we've selected our speed, 1,800 kV for this installation. The next thing that we want to make sure is that we do any other upgrades that may be necessary. On the TRX-4, you really don't have any upgrades that are necessary for brushless power. There's videos on YouTube of guys that have been throwing like 3,800 kV motors on 6S LiPo with, making a rig that goes 50, 60 miles an hour, and they still haven't broken parts, which is extremely impressive for a crawler. What I would maybe consider is changing your pinion. The rig comes with an 11 pinion stock, and I actually think the gearing between first and second speed is just about perfect for this speed of motor, 1,800 kV again. So I'm not going to change that. I'm going to keep that 11 tooth pinion, but if you want better low speed control and if you have too much wheel speed in either first or second gear, you can always go down to a 10 tooth or a 9 tooth pinion. So maybe you want to do that. In my case, I don't, so there's really no upgrades to do other than actually switching out the electronics. Pretty easy install. Now, there's really nothing else to talk about, I guess, so I'm going to button this up and then we'll go outside and do some testing. All right, we're outside ready to do some crawling, and right now I have the Mamba X ESC hooked up. I did some setting changes to make it better for crawling, specifically high startup power, 30% drag brake, let's see what other changes that I made to it. Put a little curve under the throttle, and 100% reverse, 100% forward, maybe a couple other changes. Don't remember right now, but we'll get on the computer soon enough and check her out. All right, so basically we're just going to go. What you want to do when you hook up a sensorless motor is make sure that when you pull forwards you get a green light on the ESC and that it goes forwards with the green light, and we're good. If it went in the wrong direction, then we could just swap two leads on the sensorless motor and it would change directions for us. You can only do that on sensorless though. Don't attempt that on a sensored motor, you will fry your ESC and or motor. All right, we'll get going here. So as you may be able to hear, the motor is a little bit louder than a normal motor, and that's because it has so much, magnets and rotating bell. There we go. We need to lock our diffs. It's pretty much an effective speaker is what it really boils down to. And on the BLE controller, we do have an adjustable switching frequency that gets rid of this noise for the most part. Put it into 18 kilohertz switching frequency. The Mamba X does not have that feature, and so we just got to deal with the noise. And right now we're running with the body off so you can kind of see things working. And for sensorless, I got to tell you, this is fantastic low speed control. Now let's start up in a bind here, no problems. Uh-oh. That's the only downside of not running a body. Yeah, we're good. Well, while we're down off the rocks, let's go ahead and give her a speed test. Here's our second gear. Yeah, she's real close to stock. Real close to stock. That 30% drag brake just locks up the tires. All right, back into first gear and see if we can get up here. The Mamba X has a pretty unique sound to it. Kind of Star Wars-ish. There we are. Ah! We killed our crew. All right, hand of God one more time. We'll give it a shot. Almost feel like I need the wheel speed of second gear to bump up this easily, because the Revolver just drives a little bit different, and honestly it's been so many years since I've had one installed that it's going to take me a little bit of getting used to, but yeah, it walked right up then. No problems. Now the benefits of the brushless are, besides the higher torque, higher power, is really the longer run times that you can get from them, and of course the lack of maintenance. And for a lot of folks, the trade-off between the low speed control, because brushless just really doesn't perform as good as a nice brush motor, the trade-off to get that long run time is worth it for most folks. And to be able to go sensorless and still get this kind of crawling resolution. Here's our first gear top speed. Absolutely fine for being in the rocks. Absolutely fine. It just makes it a good value. Long term, your brushless motors aren't going to wear out, other than possibly your bearings. That's really about it. If you get them wet, you just got to make sure that you relube the bearings and dry them out. Especially sensorless. There's not as much to go wrong. So in general, my rigs that I'm not trying to compete with or have the best feel for, it's going to mostly have brushless installed these days. Although I really like the feel of the brush motors better. The Revolver has so much torque though in that low speed resolution that it's about as close as we can possibly get to a brush motor. The big rotor just really has a unique driving feel. It's kind of like driving a diesel engine versus a normal in-runner, which would be like a high RPM, small 4-cylinder or whatever, small displacement, high RPM, compared to a large displacement, low RPM diesel motor just kind of chugging around. This guy just pulls through sections. And let's see how good the sensorless startup is. I'm going to put it into second gear here, and then just bash the throttle. 30% punch control here. Pretty much no lag. Bam, going. All right. Well, I think that's enough testing. Gives you the idea of the low speed control that we can get even out of a sensorless system, as long as the motor is tuned for it. It's pretty dang good in my opinion. It's a lot better than it used to be because of the updates on controllers, between the dithered mode on the BLE or the Mamba X just having different hardware to help with the startup. It's definitely manageable, and it's kind of neat. This is one of the oldest motors that I've designed. This is going to be its 13th year. Actually, that's an old crawling motor, I guess, but a reboot of it, so to speak. So at any rate, if you got any questions, be sure to post up and we'll answer them for you. Or if you have any more videos that you want to see of this system or a different system, let us know and we'll try to get to it. And otherwise, thanks for tuning in and have a good day.